Hi everyone. So in this video, we will explore joins in Spark. So as in the previous videos, we will look at the API signature of join, right? So what does join do is it will take an input data frame, and in the join it takes three arguments. So one is an other. So other is nothing but it is an another data frame, and it takes a on, and then it takes a how, right? So other means it's the other data frame, or basically the right side data frame, and on is nothing but the condition, right? So the condition, right, as you can see here, it takes union of three things, right? So it can be a string, meaning we can give a simple string, or we can give a list of strings, or we can also give a list of column types, right, or a direct column type, right? And sometimes when we need to do a cross join, right, that is a special type of join where we don't specify a join condition, but that needs to be avoided. And finally we have an how. So how means there are various kinds of join in SQL. So inner, left, right, and full outer join, and it is optional. So when it means optional, we don't want to specify it, and if we don't specify the default value, right, as given here, right, the default is inner, right? So now let's see, right? We'll create certain data frames and then we'll start with inner joins. And so here we are creating couple of data frame. So first is the left data frame. So the left data frame, if you see, right, we have ID, and then name, age, and place join date. And in the right data frame, we have the company details, right? So again, we have the ID and then the location, right? So these are the two fields which we are interested, right, or which will be used, right? So as said earlier, right, like we are starting with inner join, right? So inner join, right, doesn't needs any basically any how, because default is inner. So when we specify, right, left join, right, like left df join right df and on id, it is going to see and match all the rows, right? Say 1 2 4 5, right? These are the four rows for which we have a corresponding row in the right data frame, right? So that will be written, right? So this is a simple scenario, right? And let's assume, right, we want to do a join based on multiple columns, right? For example, id and place in our case, right? So if you see here, it is saying place is not present in both the data frames, right? Because in another data frame, if you recall, the column name is basically it is location, right? So if we go and see here, right, see it is location. So now what we have to do is we have to do a renaming, right? So that we can do like this, right? We are doing an with column rename. So what does it does is basically on the fly, right, it will rename the column, right? But now the error is gone, but again, right, there is no output, right? So let's see why it is, right? And that is because, right, we have a issue with the column, basically the place column or the location column, right? In the right side df, it is having a uppercase, right, or first letter capital is there, right? Whereas in your left df, it is all smaller case, right? So that is the problem. So to sort out this problem, that is where the data frame API will come in handy, right? So the other type of join is, right, we can give a list of columns, right? So to give a list of column, right, again, this is the syntax. So if you see here, left df, and we are selecting the id column and we are checking the right df id column, right? And as you see here, by verifying the type, it is again a column, right? So which is what we are expecting, right? So if you see the signature of it, so it is a column type, right? And we could see, right, in the bottom when we show the type, um, yeah, if you see the type, right? So type is nothing but it's a python function, inbuilt function, which will give you what is the type of this variable, right? So this expression, right, it again returns a column, right? So we are good to go, right? Now let's redefine our thing, right, and verify this, right? So we did a inner join based on id. Now instead of that, now we are doing an inner join by giving a column, right? So this is one of the signature, right? So this left id equal to right df dot id, which is again giving you a column type, that is the expected one, right? Then the other signature is we can give a list of columns similar to list of string. So here we are going to join based on two columns, right, like id and place, right? But now still, right, the problem still persists. The reason is because we have a issue with the case sensitivity, right? So let us fix the case sensitivity, right? So what we can do is we can do a left join, right, df, and since column, right, we can use the lower function, right? So quickly when we go and check the lower API here, right, so we can go and check the lower API, right, on this doc. So this will basically give you, if you see here, right, we should see the function dot lower. So what it will take is again, right, simple as that. It will take a column or name. So we are passing here a column, right, which is correct, and it returns back a column which will do the lower of it, right? Now since it is lowered, we could see both the data is getting joined, and we could see the matching data frame or a matching row, right? So one key thing, right, which we have to ensure while we are doing a join is null, right? Null is something which is unknown, right? So meaning, let us see, right, what will happen. Say for example, we have a df here, right, on the left df we have two dfs, right? In left df we have this row, right, this row number 6 which is null, and in the right df, right, again we have the row number 5 which is null, right? But if you see the output, right, we will not get that row when you do an inner join. The reason is because null and null which will not match, right? So which is good in certain conditions. In some conditions, right, we might need to match null to null, right? So how can we do it, right? So why null and null will not match is because that is the SQL general null theory. So what it will do is say null equal to null. If you try to check, right, if you see, right, all these are null, because anything which is null when equated to some other thing on the other side, it will always return null, right? So now let's assume we have to do a safe null safe join, right? So what we can do is we can use this notation, right? If you see, right, the equal to is having a greater than and less than, right? Now null equal to null, it is returning true, and null equal to true, right? No, it is not true, it is false, right? Now you can see the things getting changed, right? Now what we will do is we will apply the same, right? This is a SQL API. If you think of data frame API, right, we got to use this equal null safe, right? So now when we use this one, I think it will get fixed. So now if you see here, right, you are getting 1 2 3 4 and then the null row as well, right? And I have just kept the original one, right, without the null, to show you, right, that difference is clear. If you see here, here we have the sixth row, right, and both are getting like both are getting displayed, right? And the same can be done like done using SQL expression as well, right? So we can use the f.expr function where we can give a SQL syntax, right? So for doing a SQL way, right, we need to add some things like aliases. Let's see why it is, right? So let's see, right, like if you want to do a join between two dfs, right, you need to do a uh, like qualify that, right? Like say we cannot put id equal to id, right? Then the system will confuse whether it is for left data frame id or right data frame id, right? So to avoid that, we have to add something known as alias, right? So this alias, again, if you go and check the source API, right, it will give back a data frame only. So we are just adding an alias, and that can be referred here, right? And this will give you, right, more of a SQL way of doing things, right? So this will make your things easy, right? You don't need to add multiple things, right? And you can also do a and, right, normal and or. If you see, right, I have done a and I have done a or, right? So or means if either of the conditions is true, it will match. So you will get all the rows from a table wherever it is matching, as well as the A and B where it is matching based on location also, right? And so this is it on the join. Now let's explore the other join conditions, right? So inner join is the one which we have seen so far, right? As if you recall, right, I did not give the how class earlier. Now we can give how, and then we can give left, right, and full, right? And let's see what is happening, right? So see, as per the definition, right, it is simple. So left data frame, right, so left join will bring everything on the left side of join. So I have 5 rows in my left table plus one null row, right? So I have all the 6 rows, right? So and wherever it is matching, you will see the matching content on the right side data. So if you see, right, only for this row the id is matching with the id and place from the other table, because we have given the condition like that, right? Like it should be a null safe join on id and then on location. So only for this row it is matching. So only for this row we will have the right data frame columns value, and the same the in the right join it is the reverse. Assume you are doing a reverse of left, so you will get all the values from the right side data frame, and for the left side one only whenever there is a matching row you will get the value, right? And finally we have a full outer. Full outer is combination of both. You will get all the rows from left and all the rows from right, and wherever it is matching you will get the matching values populated on both side, and wherever it is mismatching you will see null either on the left side or right side, right? And one more thing is, right, like typically when we do a lookup, right, say we have to only insert certain rows only if it is present in maybe the parent table, or maybe if it is present in the child table, right? For those kind of things, general ways we can use a in condition. But in condition, right, if you have multiple columns, right, then you may need to concat. Say in this example, right, I have to do a insert into my target table only if id and place it is present in the parent table, right? Like a parent child relationship you can consider, right? So in that case what you can do is you can use the left semi join and left anti join. So what it will do is it will select only the data frame data from the left df, and in the right df it will not, like, see, the right df will be used only for the comparison. If you see here, right, it is just giving only the columns from the left side data frame, and in the right side data frame, if it is a left semi join, as the name suggests, it will bring only the columns from the left side for which there is a matching row on right. So for this row, we have the matching, right? ID and Delhi both are matching in the right side data frame. So only the left side columns are brought, right? And for left antigen, it is the reverse. So except for this ID2, you will get all the other rows, right? So that's all I had for today. Let's summarize the things, right? Like first we saw what is exploring join in Spark, and we saw the API. It takes three arguments. One is other, which is the other data frame, and then it takes a on condition that can be a direct string like id we can give, or it can be a list of string like id or place we can give within string, and we can give a list of columns, right? Why do we need it is sometimes when the source df columns and the left and right df, the columns if they are same you can give it with list of string. But if the columns is not same, right, meaning the column names are not same, or if you want to do a casting, right, say you want to do a lower or upper or do some sort of transformation, then you can uh, use the list of column syntax, right? If you see, right, left dot, this is the syntax for that, right, where I have fixed, basically matched it based on id, and then I have also combined it, right, and made the lower of the thing, right? And the key things to remember here is null issue, right? So null and null will not ever match, right? So in order to make a match between null to null, so certain cases you might need this, right? 90% you might not need null to null to match, but in certain cases when you do a loading, right, where you will backfill the data, or maybe where you will where null has a different meaning, right, and you might need the data to be loaded after you join, then probably you need to have this null safe join. So the null safe join will be done using two kinds of syntax. One is this equal to and with a greater than and less than symbol, or you can use a equal null safe, right, as you see here. And the difference is, you can see, even though it is an inner join, you could see the id number with null is also getting returned from the source data frame, like the left side df, right, because it is having a null safe join, right? And finally we are also seen how to do it in a more elegant way, right? Like this expr will give you directly, you can do a expression, right, and then bring it the things, right? And you can do a, like, explore the other conditions, right, left, right, and then full outer. These are the main sql joins. And the variant of left outer or left join is basically a left semi join, which can be used for lookups, right, where you want to select only the rows from the or columns from the left table for which we have a matching row in the right table, right? So lookups we can do this one, and this will be faster. I think that's it from my end, and you can like, comment, and subscribe. And if you have any queries, please do comment so that I will answer as soon as possible. And do check out this playlist, which has other videos on other basics of Spark, like select, filter, group by, order by, etc. Thanks.